Hey guys, this is Professor Janacek. I want to take a look at an example of integrating products of trigonometric functions. This is a type of U substitution. Let's look at the integral of sine raised to the fourth power of x times cosine raised to the second power of x dx. You'll notice that in this case, both the exponents on sine and cosine are even, so we're going to start with a trigonometric formula. I like to start by trying the half angle formula. If that doesn't work, I'll try the double angle formula. There are a few versions of the half angle formula. I'm going to look at the version that has sine squared and or cosine squared in it. Because I want sine squared and cosine squared, let's start by writing this as sine squared of x squared. And now I'm going to use those half angle formulas. Sine squared of x is 1 minus cosine 2x over 2. Of course, that was squared. Cosine squared x is 1 plus cosine 2x over 2. All right, there they are. That was those half angle formulas. Make sure you remember how to use those. All right, next thing I want to do, I see that this is squared, so I'm going to go ahead and square all of that. Now, if you need, you can write this as 1 minus cosine 2x times 1 minus cosine 2x, multiply it out, and then combine like terms. I'm just going to go ahead and multiply it and combine like terms all in one step. That's going to give us 1 minus 2 cosine 2x plus cosine squared 2x. Again, if you don't believe all that, multiply it out, combine like terms, it should come together. In the denominator, 2 squared is 4. And we just need to write down the rest of the stuff there in the back. Okay, now let's see. If I multiply 4 and 2, I can put those together and factor them out of the integral. So that gives me 1/8 times the integral. Now here in the integrand, I'm going to go ahead and multiply these numerators. So 1, I'm going to distribute that out, and cosine 2x, distribute that as well, and combine like terms. Again, if you need to write this out in another step or 2 steps, if you need, go right ahead. But I'm going to distribute and combine like terms all in one step. Take your time, make sure you see this. If you don't initially see it, write it all down, write it out. It'll come together. So we end up with 1 minus cosine of 2x minus cosine squared of 2x, and then plus cosine cubed of 2x. Again, take your time with that. If you don't see it immediately, write it down. Work it out. All right, let's see. What's next? Okay, I think I can integrate 1. No problem. And I can integrate a cosine, no problem. But what about cosine squared? Well, that is an even exponent. So again, it suggests that we use one of our trigonometric formulas. I'm going to do exactly like we did up here. Cosine squared, rewrote it using that half angle formula. So that gives me 1 plus cosine of 2 times my argument. My argument in this case is 2x. So it's 1 plus cosine 2 times 2x. Of course, this is all over 2, right? That was this bit. All right, now what about this bit where I have cosine to the third power? Where in that case, the exponent on cosine is odd. Now my differential is going to need a cosine. So I'm going to pull off one of those cosines to put with the differential. So let's write this as cosine squared 2x times cosine 2x. By the way, I do want to point out that this parenthesis gets closed with this parenthesis. That kind of identifies my entire argument. If you want to write those as brackets just so you don't get confused, feel free to. All right, let's see, what do we have? First two terms stay the same. This next term I can clean up a little bit, distribute the negative, distribute that denominator of 2. We get minus 1/2 minus 1/2 times the cosine, but the argument on that cosine is 2 times 2x, which is really just 4x. Okay, that takes care of that. What about this next bit? Well, remember this came from a cosine that had an odd exponent, which means we first factor out that cosine, which is what I did there, and then everything else gets changed to sines. So, moral of the story, this stuff here needs to change to sines. How do you change a cosine squared to a sine? Well, we use our Pythagorean identity. That's 1 minus sine squared. Okay. Well, I know I can start combining things if I want. I'm going to do all of that in one step. So what I want to do next before I combine things, let's just distribute this cosine of 2x there. So all of this stays the same. If we distribute that cosine 2x, we get plus cosine 2x minus sine squared 2x times cosine of 2x. Whew. All right, now this is starting to look a little complicated, but never fear, it's about to look much nicer. Check this out. First thing I notice is I have a 1 and a minus 1/2. I can combine those to give me just a 1/2. And we have a negative cosine of 2x and a positive cosine of 2x. Combine those and we get 0. So this all narrows down to 1/2 minus 1/2 cosine 4x. That term is still there. And then the last term is still there. All right, now we have 3 terms that I think we are going to need to integrate independently. So let's go ahead and separate this into 3 different integrals. The 1/8 times 1/2 dx minus 1/8 times the integral of 1/2 cosine 4x dx minus 1/8 times the integral of sine squared 2x cosine 2x dx. Okay, I can clean this stuff up just a wee bit more, not quite ready to integrate, but almost. So first let me factor out this 1/2. And let's go ahead and factor out the 1/2 on this one as well. On this last one, I don't have anything to factor out, but I'm going to go ahead and write this sine squared of 2x as sine of 2x quantity squared. I think that's going to make it a little easier with this u substitution. All right, so this next one I have 1/16 times the integral of dx. Definitely can integrate this one. This next one I have minus 1/16. Now when we integrate this, if I let u equal 4x, so u is this bit right here, what I would need for du is 4 dx, but I don't have that 4, so let's go ahead and build that. So I have cosine 4x, but I need a 4 dx there to make du in the back. I can't just go put in a 4 wherever I want. I need to balance that by multiplying by 1/4. Make sure you recognize if I were to reduce this 4 and that 4, I would just get my original integrand from the previous step. That's the setup for U substitution. Okay, I think that one's ready to go. Now on this last integral, if I let u equal to the sine of 2x, then what is du? Well, that would be cosine of 2x, and the chain rule means I would have 2 dx there in the back. Ooh, be careful. Watch that chain rule stuff. So that means in this case, I need an extra 2 in there. So let's go ahead and build that so it's ready to go. This is all the same, but here in the back, I need a 2 with that dx. Can't just go putting a 2 wherever I need. I do need to balance that. Let's multiply by 1/2 there in the front. Again, this is the setup for U substitution. If I reduce those 2's, I get the previous step. But I need that extra 2 there in the back in order to do this U substitution. All right, let's clean this up a bit, and I think we'll be ready to go. Let's see, 1/16 times 1/4, that's 1/64. 1/8 times 1/2 is 1/16. I'm also going to go ahead and clean this up here at the very, very back. I'm going to write this as 2 cosine 2x dx. I don't want that second 2 to get confused with the 2x. All right, now I think we are ready to integrate. The integral of dx is just x. That's easy enough. Minus 1/64 times the integral of cosine. We're integrating cosine of u du. What's the integral of cosine u du? Watch out, we're integrating cosine, not differentiating. That gives us sine x. So when we integrate that, we get sine. I'm sorry, hold on. Let me back up. That should be a u in there. Sine of u. There we go. If we integrate sine of u, if we end up with sine of u, u we said is 4x. So that's sine of 4x. All right. Minus this last integral, we have minus 1/16. In this case, we are integrating u squared du, right? This was all du there in the back. If we integrate u squared, again, we're integrating, not differentiating. We end up with u cubed over 3, or 1/3 u cubed. So that's going to be 1/3 times u. In this case, our u here is sine of 2x. So it's going to be sine of 2x to the 3rd power. So all in all, we have 1/16 x minus 1/64 sine of 4x minus 1/16 times 1/3, that's 1/48 sine cubed of 2x. Of course, back here when we completed that indefinite integral, we need that arbitrary constant in the back, so don't forget about that. If you integrate a 0, you end up with a constant. And there you go. Look at that. Now, there are other ways of rewriting this answer. You could factor out a common factor. You could rewrite it, factor out a common factor so that you don't have fractions. There's all kinds of things you could do, but I will stop there. Enjoy.